here. So what was it? It was anything to the 0 power is 1. And then if you have x's side by side, a, b, if they're multiplied side by side, you add the powers. And if they're divided, you subtract the powers. And then if you have parentheses like that, then you multiply, a times b. That's powers outside parentheses multiply powers inside parentheses. So, all right, there we go. Are we ready? I'm expecting you guys to get every question right now in the homework first time. I'm kidding. It's always hard to get used to actually doing them. All right, so here we go. This is section 5.1. Yeah, good question. We're in chapter 5. All we got left in this course is chapter 5 and chapter 6. Chapter 5 I don't think is too hard. These first two sections are a little bit challenging, actually. But then I was looking ahead. 5.3, 5.4 are super easy. They'll be super easy. 5.1, 5.2 are kind of challenging. Chapter 6 is a little bit harder. That's the one that's going to be a little bit more work. All right, so minus 1 squared. What has to happen there? Yeah, so what does a 2 mean on something? It means 2 of them, huh? So minus 1 times minus 1 is positive 1, 2 negatives? 2 negatives make a positive. We good? All right. Next one, minus 8 squared.
64.
What's that?
64.
So is it negative 64 or is it positive 64? Yeah, the question is how many negative signs are there? Does that equal 1 negative with 2 8s? Yes. It's actually negative 64. How would... Yeah, because there's no parentheses. If they give you negative 8 squared like that, with like the last problem, you know, the parentheses. Well, yeah, that's right. I don't need to write it. See how the one right before, there were parentheses. Okay. So that meant that the negative was repeated as well as the 1. Does that make sense? Whereas if there's no parentheses, the 2 power is only on the 8. He's not on the negative. Isn't that kind of weird? It's kind of almost like a trick. So you got to remember that. The 2 is only on the 8. It's not on the negative. So it's just 2 8s, only 1 negative sign.
Okay.
Does that make sense there?
Yeah, because
it's kind of weird, huh?
The power applies only to the number, not to the symbol.
Yeah. I know, because we think, well, look, it's 2 negative 8s. But actually, you know what it's like? It's like there's a negative 1. It's kind of like there's a negative 1 in front, and then the 8 is squared. So there's 2 8s, and the negative is just a separate thing, and there's only one of those. The 2 doesn't apply to the negative. It's not 2 negatives. It's only 2 8s with just the 1 negative. So does that make it?
And
the negative is when it's in
parentheses, yeah. Because the parentheses extend its influence. It's the whole thing.
Did you get it?
Does that make sense?
You already know this is
You good? All right. Let's try number 3. So what is 1/4 to the 3rd power? 1/4 to the 3rd power. How are we going to do that one?
What was a quarter? Oh, okay. We just go to
1/4, 1/4, 1/4. What does that come out to be?
1 over 12.
What, you can choose your calculator, isn't it?
1 over
64, yeah.
Oh, 64.
Yeah, we're multiplying, right?
Yeah.
Yeah, multiplying. So on the top is just 1 times 1 times 1 and 4 times 4 times 4. Yeah. We good? Are we all happy about that? Is that good? All right. So here, let me okay. How are we doing? So x squared when x is negative 3. So they want us to figure that out. What is x squared when x is negative 3?
It's 9.
It's either a 9 or a negative 9, huh? Yeah. So the question is it like this? Is it negative 3 like that? Because that would come out, just one negative. Remember that thing we were just talking about where the 2 would not apply? Or is it like this? Because this one would come out negative 9. This one would be 2 negative 3s, which would be positive 9. So which one is it? Those are different.
The one at the bottom.
How do we know it's the one on the bottom?
Because x, the whole value x is minus 3.
Christina, what?
X is the whole thing, negative 3.
Yeah.
It's not just the 3. It's not.
Yeah.
So
Excellent. I really like the way you're talking. Yeah. Yeah. X squared. Yeah. X squared. Yeah. See what Christina's saying there? She's saying x squared. What does x squared really mean? 2 x's, huh? I mean, obviously that's a silly statement. You all know. Let me say. And what is x? Negative 3. So it's got to mean 2 negative 3s, doesn't it? Yeah. So you guys are right. Manuel's right as well. So it is the positive. It is the bottom one, huh? Not the top one. So what that means is then to get these correct every time, whenever you plug into an x, like in a formula, you want to put parentheses. See how the bottom one with the parentheses actually gives the correct answer? But the top one, when I don't put the parentheses, gives the wrong answer? Because it doesn't carry the true meaning, like Christina was saying. The true meaning is 2 x's, whatever x is. And x is negative 3, so it's got to be 2 negative 3s. If you don't put the parentheses, it doesn't mean 2 negative 3s. It means only 2 3s with 1 negative. So that's not true. So, long story short, when you plug into formulas, you got to put parentheses around the thing, or you might not get the right answer. When I say might, it really only matters with the negative. If there's not a negative, you'll be fine either way. But if there's a negative, you'll get the wrong answer if you don't use parentheses. Everybody catching me on that? So whenever you plug into a formula, you should put parentheses around the thing you're plugging in so you're true to the original meaning. All right, so let's do that then on number 5. They're giving me minus 4xy squared. They want me to plug in x is 3, y is minus 5. So when you plug those in, put parentheses around those. How we doing? This coming out okay for you? So we get, so I'm going to do this expression here, this minus 4 xy squared minus 4. And then what is x? I'm going to put parenthesis 3. And then y is parenthesis negative 5. Oops. Oops. Sorry. Parenthesis negative 5 squared. So then what does that mean? That means negative 4 times 3 times 2 negative 5s, huh? Are we okay there? So it's negative 4 times 3 times 2 negative 5s. So how many negatives do we have altogether? Let's figure out the sign right now. How many negatives do we have altogether? 3 negatives. So is the answer positive or negative in here?
Negative.
It's
Minus
going to be
300.
negative, right? Because you have an odd amount. Every 2 minuses make plus, and then like another minus makes minus. So it's going to be minus, and then just use your calculator.
300.
300, thank you. So the answer is minus 300. We good there? Everybody see how it came out negative on that? Right? Because we got 3 minus signs.
Is there any
Um,
proper way, like order of multiplying? Like, so you did negative 4 times 3, whatever that answer was, times negative 5 times
Yeah, any order is
like-
totally fine on that. Yeah. Yeah, it'll work out any way on that. Mackenzie? Any way you want. Yeah, that'll be totally fine. You can go forward to backwards either way. Are we good on that one? What about number 6 down there? Can you see number 6? Is it too low? Here, let me make it bigger. What's the answer going to be on number 6? Y squared times y cubed?
with y to the fifth.
Yeah, side by side, the powers add, don't they? Side by side, y to the fifth, like that. Good. All right. Now, what's going to happen on number 7? Yeah, I didn't. Yeah. So let me help with that one. So 9. Oops. 9x cubed times 4x. Okay, so what's going to happen there? So 9 times 4. So the out front numbers, that's just 36. Nothing special there. Just 9 times 4 is 36. Yeah, and then what's going to happen with the x's?
They add x4.
Yeah, the 3 and what's really, when there's no x showing, we were saying that earlier, huh? It really has an invisible 1. That's right. If there's no x showing, it's really an invisible 1 is there because there's 1x, huh?
Mm-hmm.
There is 1x. And so what do the powers do side by side according to rule number 2 up there? They add up, huh? So it's x to the 4th, isn't it? Right, because this is really 3 x's, and this is really another x, so there's really 4 x's altogether. You tracking with me? Is that making sense? We good? All right, let's try. Okay, so, in fact, let me just write that bigger for you. So number 8 minus 4y cubed z cubed. And the next one is 5yz to the 6th.
What is 4y cubed?
5yz to the 6th. Okay. Yeah, so there's number 8. Okay. Let me let you try that one. Feel free to check with those around. Just see if you're getting the same answer on this one. So what's going to happen with so let's do the numbers first. Minus 4 and 5. That's just negative 20. Nothing special there, huh? Is that good so far? Just the numbers, multiply the numbers. And now what's going to happen with the y's? Let's start with the y's. Yeah, so we have y to the 3rd. And then what power's on this y? And visible 1, huh? Visible 1. So those add up. That's y to the 4th. And then what about when it comes to the z's? They add as well. Isn't that good? So the out front numbers multiply and the powers add, huh? Would that be a good way of summarizing that? So the out front numbers multiply and the powers add. So the out front numbers multiply and the powers add. Are we good? Not too bad? 6x, okay, so on number 9, 6x to the 6th, what's the other one? 5x to the 7th. And they're asking for the area, right? Yeah, find the area. How do you find the area of a rectangle?
Side by side.
Yeah, one side by the other, huh? Yeah, so basically it's just a fancy way for them to say the same thing. Multiply this by this. They're just trying to be creative and make a rectangle, but it's the same thing. So we just come in and say, okay, so it's 6x to the 6th times 5x to the 7th.
It's 30x 30.
Good, yeah, so the out front numbers multiply. 5 times 6 is 30. And the powers add 6 and 7, 13. We good? It's not too bad. Oh, and they're going to ask you for the units. Do you guys know how units work? It says these are feet, I think.
Yeah, feet.
And these are feet, aren't they?
Oh,
Yeah,
feet
both
square,
feet.
feet square.
Yeah, so yeah, do you know about units? Like if you go down, areas in square feet, like you buy carpeting or something, it's always in area, it's in square feet. So yeah, they're going to ask you for the units on that. It's feet squared like that. Just like you'd multiply feet times x, it's feet times feet squared. I think that's how they put it. Yeah, or they actually say the word square feet. That's what they do. Same thing. So I'll write that. So it's actually, I'll just write square feet. Is that good? Is that okay? Questions on that one? This one's more tricky. All right, so thinking about our rules. Yeah, which one of our rules is this? What's going to happen here?
You multiply the 1 by 12, feet 12.
Yeah, are there powers right now on the P and the Q?
1 and 1.
Visible 1 and invisible 1, huh? And so why am I showing that? Who cares? Well, then we can use the rule number 4 that says powers outside parentheses multiply powers inside parentheses. So I can, let me make it a little bigger here. So I can make it a P1, Q1, and that 12 on the outside, we'll multiply both those like that. So we get P to the 12, Q to the 12. 12 times 1 and 12 times 1. We good? It's making sense? Okay, yeah, try number 11. Try to rule, it's the same, it's that rule number 4, when you have powers outside parentheses. It's going to multiply powers inside parentheses. We good? So what's that 7 going to do?
Multiply.
Boom, boom, huh? Just going to multiply both those on the inside. So we'll get x to the 14th, y to the 6 times 7, 42. So powers outside parentheses multiply powers inside parentheses. Is that good? All these rules making sense? How about number 12? Can you do the same thing? Can you read number 12? Maybe I can make it a little bigger. Number 12. In fact, I'm going to change the letter because my S's don't look very good. Was it 5? Yeah. So R over X, let me change it to X, to the 5th power. So what do we do when we have a power outside parentheses like that?
Multiply for everything. From top and bottom.
Yeah, right. So powers out, remember the rule, powers outside parentheses, rule number 4. Multiply, well, we'll get to that later. That's the other subtraction is when it's the same base top and bottom. Yeah, good point. We'll get to that in a minute. Yeah, we're not going to subtract. If this was both x's, well, here, let me say what it is before I say what it's not. So these have invisible 1 powers, right? And so the power outside will multiply, and you'll get r to the 5th over x to the 5th, and then we're just done right there. Why can't we subtract them? Because those aren't the same bases. If they were both r, or if they were both x, then we would totally subtract them, yeah. Does that make sense? We good? So powers outside parentheses multiply powers inside parentheses. Good. Questions on that one? Okay, so on number 13, so we have a power outside parentheses. And so what it's going to do is multiply powers inside. Yeah. Yeah, let's do the numbers first off. Yeah, good idea. That -2, can we just do that part separately? That 4, that power 4 that's on the whole thing, it means 4 of everything, doesn't it? Right? 4 of this entire, I don't want to write all that out, but it means 4 of the whole thing, right? So what is -2 times -2 times -2 times -2 4 times? What's the sign first off? What's 4 minus signs?
16. It's positive.
Positive. And then if you just do your calculator, it's 16, huh? So that's the number part of the deal. So it's going to be positive or regular 16. Good so far? And now, what are we going to do for the letters?
X1 times 4. So X4.
Yeah, because there's an invisible 1 power, so that 4 is going to go boom, boom, and we'll get x to the 4, y to the 4, and the bottom, huh? That 4 also hits the 5, z to the 20th, and we're done. Does everybody see that? You see what happened there? So the power outside parentheses, that 4, outside parentheses, multiplies all the powers inside parentheses. Good. Questions? So volume. So what's the volume for a 3D shape? Volume means space inside. Like if I wanted space inside of one of these desks, in here, all this leg room that you have in these desks. What is all that space in there? How would you figure out the space? You just multiply the 3 dimensions, the length, width, and height.
It's side by side by D.
Yeah. So the volume of a 3-dimensional thing like that is just length times width times height. You just multiply this times this times this. It's really just going to be all 3 of them multiplied. It's going to be 4y to the 7th, 4y to the 7th, 4y to the 7th. Good so far? This making sense? So it's just length times width times height. Multiply those 3 together. And then, what did those 3 multiply out to be?
64.
Yeah, you just multiply the 4 with the 4 with the 4, which calculator will tell you 64. And what do you do with the powers?
Add them y to the 21.
Yeah, you add them up, y to the 21. Is that making sense? 7 plus 7 plus 7, 21. Remember, out front numbers multiply, powers add, don't they? Out front numbers multiply, powers add. This good? How we doing? We good? Questions on that one?
They're asking for
Oh, the units. Yeah. You're right. They want the units, don't they? So what is it? Feet?
cubic feet.
Yeah, so they're saying this is feet. So put it all together. It's cubic. Yeah, because it's 3 of them, huh? So cubic feet. Volume is always in cubic feet. There it is. Yeah, that'd be cubic feet. You're right.
Dimension cubic?
Yeah, 3-dimensional cubic feet. Good. Not too bad. Questions? Okay, so how do we do that one? -2 to the 8th over -2 to the 5th. Now, which rule can we use?
It's going to be 2, 3, 3.
Remember which rule number up there among our power rules?
3.
Yeah, everybody sees rule number 3? rule number 3. You want to subtract. Right? So rule number 2, when they're side, let me write this out. When they're side by side, you add. When they're vertically, you subtract. Right? Like if you have x to the a times x to the b, side by side they add, but if you have them vertical, they subtract, don't they? So side by side they add, but vertical they subtract. So that's those rules that we saw earlier. So now, so this is going to be what? 8 and 5 are going to subtract, so it's minus 2 to the third power. And then we can work that out. That's just minus 2 times minus 2 times minus 2, minus 8. There we go. How we doing? We good? Those 3 minuses multiply to be minus 8. All right, so.
Oh, okay, wait.
Yeah.
We have to simplify to the final expression that would be.
Right, yeah, we can't leave it here. They want you to go all the way to there. Yeah, that's right. On that one. Is that good? Is everybody getting the hang of this? So when they're vertical, they subtract. When they're side by side, they add. Don't they? All right, let's try that one. Let me make it bigger. That's not very big. I don't know if your eyes are as old as mine, but you can't see things that small. I guess they're not. 10x. I never thought I would need glasses. That was always for weak people. No, yeah. Sorry, I know it was an offensive thought.
Oh my goodness, that's strike 2 for you.
All right. No, it's definitely a wrong thought. All right, so try that one. Try that one. So we're going to, well, yeah, let me let you think about it rather than me just say. What's that?
0.2, y.
Yeah, so the numbers are going to divide, huh? Yeah, so the 2 and the 10, handle them just like you would a normal fraction. What would you do with 2/10? Like what normally happens with 2/10? Yeah, just make that 1/5, huh? Just 2 goes into 10 5 times, right? So that's totally right. That's just normal.
So you put it as a fraction or decimal?
Fraction. We're just gonna leave it as a fraction. So it's really just gonna be a 5 in the bottom. I mean, you can put the 1 on the top, but 1 doesn't do anything, huh?
So it's 1/5.
And then handle the letters from there.
The letters would be only y.
Yeah, what happens with the x to the 9th over x to the 9th?
They cancel each other.
Totally cancel. And then what do you do with the y's?
They subtract.
Yeah, when they're vertical, you subtract. So and so it's going to be y squared like that. So that 1 on the top's not really needed.
Oh, okay.
So it's just y squared over 5.
Y squared over 5.
Does that make sense?
Yep.
How are we doing? Something I can say to help on that? Does everybody see what happened? So the 2 went into the 10. Karina.
No, I have a question with the one before that.
Yeah.
Because it was -2 over -2. And you did parentheses -2 parentheses over the power of 3.
Uh-huh.
The one before, yeah. So wouldn't it be -2 and -2? Wouldn't that be 1?
It's not like that.
What's that?
You divided -2 with the -2, right?
Oh, no, yeah, good question. When they have powers, I just do the powers. I don't mess with them themselves. Really good question. So everybody see Karina's question. She's saying on this last one, why didn't I just divide -2 by -2 to get 1? Because they had powers. You see, when the numbers have powers, all the work is up in the power zone. We don't deal with the numbers themselves.
So you just leave that same number.
You just leave that same number by itself, and you just do the powers. That's right. Does everybody see that? See that difference there? Whereas, yeah, because if that had just been a -2 over -2 with no powers, yeah, that'd just be 1. So back over here, see how the 2 and the 10 don't have powers? So I just do them as normal numbers. Yeah. So all the rules we're learning is when things have powers, the action happens on the powers. In fact, that reminds me of a good question. You guys tell me, you're getting these rules down, right? Let me give you 2 to the third times 2 to the fourth. Are you ready? I'm going to give some multiple choice answers. 4 to the 7th, 4 to the 12th, and I'll just say none of the above. Also ABC. Are we ready? Are we ready to vote?
A.
Wait, hold on, and I'll give you all a chance. We all ready? Everybody made up their mind?
No.
Matthew's now persuaded everybody. All right.
It's not.
So how many say it's A?
Are you saying A or are you just saying?
A is closer, but it's not that we have to write it.
A? Oh, hey. I'm not sure about that. Anyway, okay, a couple people think A. How many people B? How many people think C? None of the above?
It's like right there.
What's the real answer? If it's none of the above, what should it be?
Just 2 to 7.
2 or the 7th power.
Just 2 to the 7th power? Yeah, wait a minute, guys, but aren't you forgetting what's 2 times 2?
We're not multiplying, we're not. Yeah, but we're dealing with the powers.
Are we? But shouldn't we do the powers and the numbers? So 4 to the 7th? I'm just playing with you. I'm glad I can't shake you, Christina. You're right, and what I'm saying is crazy. But this is exactly the good question that Karina was bringing up. So again, I just want to emphasize, you don't actually do the bases, huh? Just like in that other one Karina was asking about, negative 2 to the whatever it was, 10 over negative 2 to the 8, or whatever, or I guess it was 7. And you see, you don't actually divide the bases. So again, everybody's seeing the idea. When you have powers, you don't actually multiply or divide the bases, do you? You just do the power stuff.
Yeah.
Yeah, because that's what these rules are saying.
You
These
only do the
X's are things.
powers.
Everybody getting that? Is that making sense? So you guys are right. The answer should really be 2 to the 7th. You don't actually multiply the bases because they have powers. You just add the powers. Now, what if somebody said, what? Yeah.
What if the bases are different?
If the bases are different, then there's no shortcut rules. You just got to work them out. So in other words, if you had like 2 to the 3rd and 3 to the 5th or whatever, you would just take your calculator and go 2 times 2 times 2, 3 times 3 times 3 times 3 times 3, and whatever. Yeah, there's no shortcut rules. There's nothing you can do.
Okay.
Good question. The bases have to be the same for all these rules.
Same basis.
Good question. Now, let me ask this. Let me finish with this thought. What if somebody said, okay, yeah, I see your little rule there, Mr. Heron, that when the bases are the same, you don't actually multiply the bases. You don't go 2 times 2 is 4. You just keep the same base, and then you add the powers. But that just doesn't seem right. Does it? I mean, aren't we doing what's true here? When did we quit doing what's true? Isn't 2 times 2 4? What would you say to somebody who said that? How dare you question math? No, I'm just kidding. What would you say? That person is dead wrong. They're saying it feels wrong. You need to show them that their feelings are wrong. Is actually.
Yeah.
So how do you show them that? How can you show them that that's actually? You can do it. It's nothing profound. How do you show them that this is actually right? It's not 4 to the 7th. That's not true. How do you prove it?
Okay, we
Yeah.
open the 2 times 3. We go 2 by 2 by 2.
Yes.
Then
You guys are right on the money.
4 times the 2.
Yeah. You say to them, well,
We go graphic on the
what
2.
does 2 to the 3rd mean?
Yeah.
2, 2, 2. And what does 2 to the 4th mean?
2 times 2.
And so what do we have there? 7 4s?
It's
It's 7 2s, huh? So it's true. You don't actually multiply the bases. Why not? Because it would be wrong. Right? Because it just wouldn't be true. No matter what we feel. Right? Everybody good with that? You see that? Good. So always come back to the basic meaning of what it is. The rules are following the truth. They are.
It's like always go to the basics, huh?
Yeah? Just go to the
And
basics.
then you got it right.
Then you got it right. Good. Is that making sense on that? So a good lesson is learned. When things have powers, we don't actually mess with the bases at all. We just do the powers because that's true. Huh. Right? That making sense? Okay. So what's number 17? Minus 6x to the 0 power.
It has to be this one, but the reciprocal. You get a fraction. You convert it into a fraction. It's 1 over 6x.
You guys are cracking me up.
Yeah, it's 1 over 6x.
What does this rule say?
It's 1.
Don't ever forget the rules. Yeah, so what does the rule say here? Let me write it out a little bit better. So minus 6x to the 0. Remember, we have the rule number of the rules. Rule number 1 says x to the 0 is 1.
Number,
And that can be anything. Remember that x,
Even if it's in parentheses?
yeah,
But this is
especially
inside
when
the
it's in
parentheses
parentheses.
already.
I'll explain what I mean by that in a minute. Yeah, so this means anything, huh? That x could, whenever we write an x in math, we mean anything could be there, huh?
Yeah.
Anything to the 0 power is 1. Anything to the 0 power is 1. So, what is minus 6x to the 0 power?
1.
What if they gave you, well here, let's do the next one. Number 18 is 12 to the 0 plus y to 0. Number 18 is 12 to the 0 plus y to the 0. What's that?
It's 2.
I mean,
You get 2 there.
Yeah, because 12 to the 0 is 1. Y to the 0 is 1. 1 plus 1 is 2.
2.
We good? Anything to the 0 power is 1. And you saw it demonstrated as truth, right? Is that making sense? You want a lot of these on the next exam?
Yeah, let's go.
How about like 1,516,283 to the 0 power?
It's 1.
Oh, let me make it negative. Negative
It's 1.
is 1, right? Obviously, right? Now, is there any way this could be made tricky?
If you put a fraction under.
All right, let's see how good you're getting at following the rules. You ready? I promise I'm going to obey the rules. I promise to obey. Do you promise to obey the rules? Do you have a comment, Christina?
what if it's not in parentheses?
That's where I'm going. You're sensing where I'm going. Yeah. Think about this. Do you question? Comment? Asia?
I don't, it was number 18, are you still working on it?
Oh, I'm just making stuff up now. Yeah. 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 18. Here's 18 again. Did you miss that one?
I didn't get how, the 12 to the 0 power was 1 instead of 12.
Yeah. Well, that's just simply the rule. Anything to the 0 power is 1. So if they wrote 12 without showing a power, that would be just 12 because there's really an invisible 1 there.
I get what you mean.
So if no power is showing, it really means 1. If they actually write 0, then the whole thing becomes 1.
Okay.
1 plus 1, 2. Yeah. All right. So I'm going to try to trick you now. I'm going to do my best. I try with all my might to trick you in lecture, so I will not trick you on the exam. That is my desire. I don't know if you believe that or not, but I don't want to trick you. I want to show you all the tricks before we get to the exam. So here's a trick, a curveball they like to throw at you a lot. It comes like this. Now, I'm going to prep you for the curveball. Remember the difference between like minus, well, here, yeah, let's do this. What is minus 3 parentheses squared? What does that come out to be?
9 plus.
Yeah, positive, right, because it means 2 negatives, positive 9, right? Versus, what if they don't put parentheses?
You just apply to the 3 minus.
Then the power, think of the significance of this, the power, if there's no parentheses, the power only has power over the immediate number, not even the minus sign, unless parentheses extend his influence, right? So the power only powers the 3 here. The minus just sits there, like we talked about a few minutes ago, right? The minus just sits there, and we have 2 3s, and it comes out minus 9. So that matters, right? Are you ready? Here comes the question. Minus 5 to the 0 power.
It's just 1. Minus 1.
It's just 1.
No, it's
It
minus
doesn't apply
1
to the
because
minus
the
sign.
0 applies to the 5, but not for not the symbol. The symbol stays there.
Right. So we get to
Come on.
So a 0 power on anything makes it 1. We all know that. But the question is, who is that 0 power have power over? The whole thing or just the 5? Just the 5. That's what we learned, right? If there's no... So he's going to turn somebody into a 1. Yes, that's true. But who? Just the 5. He doesn't touch the minus sign. Unless it has parentheses, right. So if there were parentheses, so this one's -1. If there were parentheses, then that whole thing would be regular positive 1, wouldn't it? Everybody see the difference? A 0 power turns whomever he has power over into 1. But you got to be clear who he has power over. Does he have power over the whole thing? Then the whole thing's 1. Does he have power over only on the 5? Then only on the 5 becomes 1. Right? Now you know it. You won't be fooled on the exam. You'll remember that in 2 weeks. Right? There you go.
If I put it on my card.
You have to put it in my card.
That good? You'll be thinking about it for all 2 weeks. All right.
Okay.
We good there? 1/8 squared.
4 squares per inch, 5 squares per inch.
1/8 squared?
64.
That's just 1/8 times 1/8, huh?
Yeah.
Which is 1/64. 1 times 1 and 8 times 8. We good? All is well? All right, let's keep going. Number 20. It's 8 to the 4th, 5th, 7th. All right, try that one.
Those are A's or negatives?
Those are A's. Just A's.
8 to the 16. I had the same problem.
Add them up, huh? We just add them up. So 16?
16, yes.
Good. Okay, could you simplify that one?
That's 17. Is it 5 or 5? It's 5?
Fifth.
5?
So remember when they're side by side, the powers just add. We good? Like if we had a power outside, we don't. But if you had like a 3 or something outside the parentheses, then that would multiply the powers inside. But we don't have that. You with me? We just have side by side. So the 7 and the 10 make 17. Yeah. The 4. And what's the other power? What's power on the other y?
1.
Yeah, invisible, understood 1. So that's y to the 5th, huh? We good there? Good? Make sense? These rules work. Says n to the 6th, all to the 2nd. Give that one a try. So what do? Do we add the 6 and the 2, or do we multiply the 6 and the 2?
Multiply.
Yeah, because that's rule number 4, right? Powers outside parentheses multiply powers inside. Question? Good? Good, that making sense? So 6 times 2 going to be 12? So powers outside parentheses multiply powers inside parentheses.
Just powers?
Yeah, just powers. Yeah, do you have like a different situation you're looking at?
I'm on the next problem and I got it wrong and then did that.
Okay, yeah, we'll take a look at it. So let's see, it's minus 2xy to the 5th. So is that 23, right?
Yeah.
Minus 2xy z to the 5th, all to the 2. Is that right? Minus 2xy z to the all to 2. Yeah. All right. Yeah. Try that one. So yeah. So powers out. So do just what we're saying. Powers outside parentheses multiply powers inside. Yeah. What about that -2 in the front? What's that going to do?
Leave it alone.
Well, remember the 2 does mean 2 of these, huh? Right? So it does mean, we don't necessarily want to write all that out. But you should realize in your mind that means 2 negative. It means 2 of everything. So it does mean 2 negative 2s. Are you with me? There's a couple ways. I'm kind of debating in my mind which way to show you. How about this? Let me do it the other way. I think it'd be more clean if I just did it this way. Just treat that -2 like you would any other letter. What do I mean? He has an invisible 1 power, 1 power, 1 power. What's that 2 going to do? Multiply, 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 multiply. That's a little more clean, I think. Just think of it that way. That's true. Right? That makes sense? Powers outside parentheses. Everybody has a 1 power. Anybody not showing their power really has an invisible 1 power.
Yeah.
Right? And powers outside parentheses multiply powers inside according to rule number 4. Now, the only trick with that, though, the reason I hesitate to show you that way, the only part that's a little tricky is figuring out the sign, positive or negative in the end. Can you tell what that's? Let's just do that as a separate thing. Is it going to be negative or positive in the end, and why?
Positive.
Positive because there's 2 minus signs, huh? That minus is under the power of the power. He's in the parentheses. So he's repeated twice. 2 minus signs plus. Yeah. So it's going to be plus, and then the rest is true. 2 squared, x squared, y squared, z to the 10th. And then what do you do with 2 squared? What is 2 squared? They don't want you to leave it that way. For the numbers, they want you to multiply it out.
4.
That's 4. 2 times 2 is 4. So 4, x squared, y squared, z to the 10th. Is that making sense? Powers outside parentheses, multiply powers inside. And remember, anybody not showing their power really has an invisible 1 power.
Invisible 1.
Good. All these rules coming together for you? Nine x to the 8th over x to the 7th. So what do we do there?
9x.
Yeah. So when they're vertical, we subtract them. When they're side by side, we add them. When they're vertical, we subtract them, huh? Yeah. So 8 minus 7 is just going to be x to the 1. The 9's just sitting there. He's not doing anything. So it's just 9x. You don't even need to show the 1, do you? It means 1 even if you don't show it. Just 9x. That good? Easy enough. All right. How about the next one? Question?
On the homework, is it gonna want us to put the 1?
No.
Yeah, I think he just wants you to leave it off.
Yeah, I tried it right now.
If you put the 1, does it hassle you? Does it?
I didn't put the 1.
So yeah, it's certainly good without the
Just
1.
put the letter.
Yeah, just put the letter. Yeah. All right. How about 9 CD all to the 2nd power?
That's 81 c squared d squared.
What does the power outside parentheses do? Multiplies the power. They all have a 1 power, don't they? Right? Even the 9 has its own 1 power. So that 2 is going to go boom, boom, boom. And it's going to be 9 squared c squared d squared. And then we don't leave 9 squared. What is 9 squared? 81. 9 times 9. 81 c squared d squared. We good? All is well? Questions on that? Okay. So try that one. Yeah, take that power outside parentheses. Multiply powers inside parentheses.
The bottom next one.
Yeah, and then reduce it. So if you get a fraction, which you will, 16 over 64, yeah, reduce that. Reduce it as far, like you always do with fractions. Reduce it as far as you can.
So 1 4. 1 4 4 9 to the 20.
So that 2 on the outside. There's, here, let me make it a little bigger. So 4m squared, 8 into the 6, bless you, with a 2 out there. So that 2 on the outside, there's really a 1 power on the 4 and the 8, huh? Did y'all fill that in? And then that power, that 2 outside, will multiply all the powers inside, huh? So we get 4 squared m to the 4th over 8 squared into the 12th. We good there? So far, so good. And then we got to work out the numbers, huh? So 4 squared is 16. And 8 squared is 64. And then on your calculator, you could just divide. 16 goes into 64 4 times, right? So just a 4 on the bottom and 4 into the 12th on the bottom. So m to the 4th over 4 into the 12th.
And 4.
Does that make sense
Yes.
on that? How we doing? Is that good? Questions can I help with that one? Any questions?